2 by 2 matrices, we want to prove that the determinant of a nilpotent matrix is 0. So nilpotent matrix, in this course, that means that A squared is equal to the 0 matrix. Let's consider a general matrix A, B, C, D, and then let's square it. So that's going to give me A squared plus BC as the top left element. Remember, top times left gives top left. Then top times right will give top right, so that's AB plus BD. Then for bottom left, we're going to get AC plus CD. And then for bottom right, we'll get BC plus D squared. So what we have to have, if this is going to be the 0 matrix, is that A squared plus BC is equal to 0. AB plus BD, which we could write as B, A plus D, is equal to 0. This one could be written as C, A plus D is equal to 0. And finally, we'd need BC plus D squared is equal to 0. Let's call these 1, 2, 3, and 4. Now, if we look at these two in the middle, there's really two cases that suggest themselves. The first is that B equals 0 and C equals 0. And the second one is that A plus D is equal to 0. So these are two cases. I'm going to call them case A and case B. So let's examine case A, which is that B equals 0 and C equals 0. From 1, that means that A must also be 0. And from 4, that means that D must also be 0. So in other words, our matrix A would be 0, 0, 0, 0. And that means that the determinant of A would be 0. Now let's examine case B. So A plus D is equal to 0 means that A is equal to negative D. So our matrix ABCD could be written as ABC minus A. And the determinant of A would be minus A squared minus BC, which is negative A squared plus BC, which is equal to 0 by equation 1. So in either of these cases, the determinant turns out to be 0.